All right, we are starting the second section of chapter 8, and we're going to investigate the reciprocal graphs a little bit more than what we did in the homework with just using the calculator. So this right now is the graph of the basic equation y equals 1 over x. That's really what we're focused on this chapter, is what happens when x is on the bottom. So the first thing I want to introduce you to is a new term, which is called asymptote. Asymptotes are these dotted red lines in this particular example. Those are asymptotes, and they represent a line that the graph is allowed to get closer and closer and closer to, but it's never allowed to cross it. So as you see, the blue lines are the graph here. They're getting pretty close, but they're never going to cross over that dotted line. So with that being said, if we try to look for the x-intercepts here, if we take a look, this is all dotted on the x-axis, so the graph is never going to touch the x-axis, so it actually has no x-intercepts. And then similarly, if we tried to look for the y-intercepts, there's a dotted line on there, so there are no y-intercepts. So that's a part of the graph that the reciprocal function graph completely ignores. It's not allowed to cross over that. All right, then when we start to talk about domain and range for these functions, so what we have to think about is the spots where the graph does not exist. So domain, we start with the phrase all real numbers. And then we look at, for domain, remember that's x. We're looking for the spots that it doesn't touch the x-axis, and we know that's where the asymptote is. So it's all real numbers except x equals 0. And then for range, it's going to be all real numbers except we look at where it's not going to touch y. So we're looking at that horizontal asymptote, and we know that it will not touch at y equals 0. So except y equals 0. So this was our except x, that's our except y. So this is when the graph hasn't moved at all. What we're going to be working on next is what happens if the graph does. All right, so on this page, we're going to talk about what a, h, and k do to the graph. And these we've seen before. So the a we saw in yesterday's notes when we use the graphing calculator to graph these. This is what switches what quadrants it's in. So when I talk about quadrants in here, this is quadrant 1, this is 2, 3, we just go counterclockwise around, and this is 4. So when it's positive, we actually see it graph in quadrants 1 and 3, versus when it's a negative a, it'll graph in quadrants 2 and 4. And then these next two should look familiar. We've talked about these before. If it's bigger than 1, it's going to be a vertical stretch, which really means it's going to pull farther away from the origin. And if it's between 0 and 1, it's a vertical compression. And then the plus h and minus h, these go back to what we've talked about before. For these ones, we do have to think opposite, because that's the one inside of the function with x. So plus h is actually going to make it go left, and minus h will make it go right. What I need you to know is that left and right changer is actually going to be what affects our vertical asymptote. So the vertical asymptote will be at x equals h. Still thinking opposite when we look at the h. And then lastly, the k of the graph is the one that shifts it up and down, which means that is going to control the horizontal asymptote. It'll tell us that the horizontal asymptote is at y equals k. So let's go ahead and try to practice these. So the first thing I would want you to do for any of these problems is figure out where both asymptotes are. Each of these graphs is going to have an x asymptote and a y asymptote. So you just need to make sure you're looking at the right spot. We get the x asymptote from looking at the bottom here and looking at our h value, which is -2, but we got to think opposite. So that the asymptote for x is going to be at +2. And then we look at the k value to find the y asymptote. That's going to be at +3. once we have those written down, we should graph them. So x is going to go through positive 2 on the x-axis, even if you want to put a little dot there so you can see it. We're going through positive 2 on the x-axis, and then on the y-axis I need to go through positive 3, and I'm just making dotted lines through those points. And then to graph the branches, we look at our a value and we decide if a is positive or negative. So right now we have a positive a value, which means that we're going to be in quadrants 1 and 3. If you want to get a little bit technical with that a value, it actually tells you how far to move diagonally out of the origin, how far pulled away it's going to go. So I'm moving diagonally 1, and then I'm just going to draw in my branches in those quadrants. Trying not to cross over the line, but still stay next to the line on the far ends. It likes to be close to the line, but not cross over it. This one got a little crookedy, so we'll fix that. So hopefully that part makes sense. Then we also want to do domain and range. For domain, remember we're thinking about x, so it's going to be all real numbers except where the x asymptote is, which since we already wrote that down, it's a little bit easier, except x can't equal 2. And then for range, it's all real numbers, except y can't equal 3. So hopefully that makes sense. This is pretty straightforward. I'm just really looking to see that your asymptotes are in the right spot and that you're drawing your branches in the correct quadrant. All right, if we look at this next one, again, for the asymptote, we look at the bottom. So if there's no number there, that means that h is 0 right now. So the x asymptote still exists. It's going to be at 0. Just because there's no number doesn't mean there's none. It always has an x and a y. And then for the y, we look at k. I know y is going to be negative 2. And we're going to go ahead and graph those. So the x1 is going to be at 0. So we're going to go vertically through 0. And then the y1, if I put a dot at negative 2, we're going to go horizontally through negative 2. And then for this one, to decide the quadrants, I'm looking at the fact that we have a negative a. That tells us that we have to be in quadrants 2 and 4. And again, you can use that number to move diagonally the amount that it's supposed to stretch. So it's going to be 1, 2, 3, 4 diagonally from where the two asymptotes cross. 1, 2, 3, 4. And then we can go ahead and draw the curves. And again, they're still going to stay on the far ends close to the asymptote. But it's got to look like it's curving in when it gets to the asymptote because it's not allowed to cross over it. And then I'm just going to show you a shortcut on this page. A new symbol that I can show you guys is this guy. It's like 2 lines and then writing the R around it. That means all real numbers. So for domain, instead of writing that out each time, you can just do that symbol and then tell me what x is not allowed to be. X can't be 0 because that's where the asymptote is. And then for the range, it's all real numbers, but y can't be negative 2. So hopefully that shortcut just saves you a little bit of writing. All right, moving on. We're going to do one more together here. So again, to get the x, we're looking at the h value, but we have to think opposite. It's really essentially taking that bottom and setting it equal to 0. So the x is going to be at negative 4. The y, again, there's no number, so I need you to think of the fact that there is an invisible 0 there. So the y asymptote is going to be at 0. So if I go to x being negative 4, that's where I'm going to draw the vertical line. And then I'm going to go to where y is 0, and I'm going to draw the horizontal line through there. And then our a value is positive right now, which means we're in quadrants 1 and 3. So then, if we look at it, it's technically 1/2. So this one's going to come a little bit closer. It's a little bit snugger when it's a compression. So it's going to look something like this. And then something like this. There's not really any way, I know I'm not in Notability right now, but when you're in Notability, there's no good way to draw these curves. Sometimes when you try to draw it in Notability, it's going to draw a curve like that, but we want to make sure that we're staying close to the asymptotes. So you really want to just hand draw these. And then lastly, for the domain, we just have to write out it's all real numbers except for where the asymptote is, so x can't be -4. And then for the range, we're looking at all real numbers except for the y asymptote, which is y can't be 0. So hopefully this lesson is starting to click for you. It's not too complicated. You just gotta, again, get the asymptotes in the right spot and get the curves in the right quadrant. Alright, so I would like you to pause this and try this one on your own. And then I will fill it in. Alright, so checking in on that first step, for the asymptotes you should get x is equal to -3. Again, we get that from looking at the bottom number here but thinking opposite. And then y is equal to -1. And I drew both of those in. X is at -3, y is at -1. And then to draw our curves, we got to look at that negative sign. So I know since it's negative, it's supposed to go in quadrants 2 and 4. And we're technically 2 out diagonally from where those cross. So we're going to be there and there. And then we can go ahead and draw our curves, staying close to the asymptotes, nice and snug, but not crossing over, not even looking like it's going to cross over. It should flatten out as it approaches that asymptote. So it should look like that. Hopefully we got that. And then for the domain, it should be all real numbers, but x can't equal the -3 where the asymptote is. And this is all real numbers. But the x can't not x, whoops. The y can't equal -1 because range is y. Alright, the last thing we're looking at is actually just the opposite. They're going to give us the x asymptote and the y asymptote, and you just got to make sure you plug those in to create that. So this is going to be going in for h, and this is going to be going in for k. We just have to make sure for the one for h, if we want it to come out to be positive or -2, we actually have to put +2. So you got to be careful with the h one. It's still got to be opposite. And then if we want +3, it would have to say +3. So you're just plugging the h and the k into the right spot with the right sign, and that's the answer. The 5 they started us off with, you're going to keep that to keep it the same. So go ahead and pause the video and try the next one. And now I'm just going to go ahead and set it up. We're going to keep the -3. And then the x one being +5 means on the bottom I want to see x -5. It has to say -5 to get +5. And then if the y is supposed to be -1, that's going to be a -1 at the end. So we're just kind of working in reverse. They gave us the asymptotes. We're creating the equation that would give us those asymptotes. Alright guys, please make sure you submit these notes when you're done filling them in. That is part of your grade for today. And then you also do have a homework assignment to go ahead and get started on and turn in by class time tomorrow. Thanks guys, have a great one. See you soon.